All right, everyone. So let's go ahead and get started with today's lesson. As always, by this time, you should have your warm-up submitted into Schoology. You should have your journal out, open, and ready for us to begin. So as you can see for today's lesson, we're looking at identifying functions. Identifying functions. So we have finished with our first unit on equations and inequalities. We are going to be going back through that, so don't forget that information. You are going to be seeing it throughout this time period. But let's jump into identifying functions. We're going to start with basically a real world situation and just kind of putting into our mind how and why this works the way that it does. Okay, so let's say we have a vending machine in the cafeteria and it contains these items. Okay, we have a vending machine in the cafeteria that contains these items. Our first question asks us, if Carson inputs B3, what item will he receive? Okay, if he inputs into the vending machine or presses B3, what item will he receive? Okay, well, let's look. Okay, so we go to the B column, right? B column at the third row, we know that he's going to receive a Twix bar. Okay, Carson inputs B3 and he gets out a Twix. Okay, so if he puts in B3, he's going to get out a Twix. Okay, if Blaine inputs A2, what item will he receive? Okay, so we have A column 2. Okay, so Blaine is going to receive trail mix. And if we have 5 people in a row, okay, 5 different people standing in line, they are all going to input B4. What should they each receive? If they're putting in B4, they're all going to receive Reese's. Okay, and this is basically how functions work. Okay, we're looking at what is going in, or what is the input, and what is the output. Okay, what is going in and what is coming out. So we're going back over here to our notes. Okay, we'll come back to this situation in a second. Okay, so a function is a relation or a rule that assigns each input exactly one output. Okay, a function is a relation or a rule that's going to assign each input exactly one output. So notice in the situation, if I push B3 as my input, I only had one output, which was a Twix. Okay, if I inputted B3 as my input, my only output was a Twix. If I inputted A2, my only output is trail mix. That's the only option I have to get out based on what I put in. Okay, so that means in the mathematical term that each x value, okay, that means that each x value is going to be paired with exactly one y value. Each x value is paired with only one y value. Okay, so this is not our first time seeing functions. We've talked about functions. We're just going to extend it just a little bit here in Algebra 1. Okay, so each x value is paired with exactly one y value. A graph that is a function will pass the vertical line test. A graph that is a function will pass the vertical line test, where any vertical line drawn on the graph will pass through only one point. Okay, any vertical line that is drawn on the graph will pass through only one point. Okay, so keeping that in mind, okay, let's go back to our vending machine example. Okay, would this vending machine, like this one that is shown, be an example or a non-example of a function? Based on what we just said, each input has its only one output. Okay, for A1 M&Ms, A2 trail mix, A3 chips, A4 pretzels, all of my A values, okay, only have one output. Same thing for B. If I put in B1, all I can get is Skittles. If I put B2, all I can get is Snickers. If I push B3, all I can get is Twix. If I push B4, all I can get is a Reese's. So with that being said, this particular vending machine would be an example of a function. Okay, it would be an example of a function because each input, we're going to say button that you press or something like that, each input or the button will only give one output. Okay, or food item in this case. So our input is what we pressed in the vending machine, while the output is what is the food item or candy item that we received. So in this example, this would be a function. Okay, this is an example of how a function works. What we put in, we should only be able to get one output for that. Okay, if the vending machine removed all the Skittles and had M&Ms, if I remove all of my Skittles, right? If I remove that and I replace it with M&Ms, okay? And now both A1 and B1 have M&Ms, would it still be a function? A1 is an input, B1 is an input, okay? The answer here would be yes. This is still a function. The inputs of A1 and B1 will still have one output. Moving fast. Okay, the inputs of A1 and B1 will still have only one output. Even though the output is the same for both of them, the inputs are different. Okay, so we're focusing on each input having one output or its own output. Okay, just one output. Let's look at what do functions look like. Okay, just remembering, it says for each problem below to circle the letter of the representation that is a function. Circle the letter of the representation that is a function. I'm trying to bring this down some so we can see a little bit better. Okay, so for each problem, write the letter of the representation that is a function, then write a sentence to explain why the other representation is not a function. So what type of representation do we have in number 1? Okay, both of these are tables. Okay, this is a table representation. Okay, table representation. Let's look at A. Okay, my input is -9, 1. I have 4 and 3, 6, -1. I have -9 again, but remember, if I have -9, it should have the same output as here, right? -9 should only have this one output of 1. -9 over here has 13. Okay, so we're going to circle that and we'll come back to it. Let's look at B. I have 2, 5, 4, 5, 6, 5, 8, 5, and 10, 5. Even though all of them have an output of 5, all of the inputs are different. Remember, each input can only have one output. So because these inputs are different, them having all 5s doesn't really matter. Okay, so our function in this case is going to be B.